Hello everyone, welcome back. Let's just start with training our models. Before we go ahead, now in the previous video we saw the number of records which we got after doing this mode balancing is this much, which is 49,692, while what we had was 31,671. So let me take it over here and try to check it out. What's the case? Okay, so over here what I'm going to do is, my hunch is that I mean, not the hunch, that's what it is, right? Whatever the minority class is there, for the minority class it creates the synthetic records, and for that it uses the techniques called KNN, K nearest neighbor, etc. That's what happens behind this mode. Okay, now let's just see how many the final data which we have got, that is balanced target. In the target column we had we had just somewhere 26,000 of records, right? So in target, if you would see target dot shape, we had this many records. Target dot shape, or maybe I should say dot group by, I'm not sure if group by will work on this. Group by, let's see, it is not going to work on this. What we can do is we can directly see on the scale combined, right? For target, how many things that we had. Group by, and into this we are going to look at target. Okay, and dot size. What we saw was count. What is the problem? It says target is not available. Why? Scaled data combined. In the scaled data I should have target column available, isn't it? In this scaled data I should have this available. Dot head into this loan status. Oh, oops, sorry, my bad. That was named as loan status. Group by into this loan status, and dot size. Let me see how many records that we had got. So you see these many records we had. Now what I'm going to do is, after balancing, what I'll do is I'll just try to have a look on this the distribution. What is the distribution that we have? Balanced target df equals to pd dot, what is od? There is nothing called pd dot data frame, and inside this I'm going to say target, that's the column name, and over here this is what I'm going to use, because this is nd a numpy array, so that's why we have to take it like this. Okay, so this is done. Now after that, again at the same thing I'm going to perform over here also, and let's just put target over here and see. Now what you see over here is, previously in the target column what we had was only 6,825 records were in positive class, and in negative class we had these many records. Now over here you see positive and negative both are in same proportion. That's why we are saying our data is balanced. Great. So now you understood the importance of using this smooth, right? It has just made the proportion same, right? So that's where it is going to be very, very important. All right, so what I'm going to do is I'm just going to delete this all, because that was just for the validation purpose. Okay, now let's just see, or maybe I can move it above. Let's just skip it over here, so that in case if it is required, we will have it. Now let's just see, we will start with training our model. So there are a couple of models which I'm going to train over here. Now just stay with me, you would learn a lot. All right, so before we start with the model, what we need to do is we need to classify our data in train test split. Over here, we have the set of features and targets. Now we need to classify that in training set and in the testing set, right? So for that, what we need to do is from sklearn. Now, whatever libraries and module I'm importing over here, in case if you are struggling to have them installed in your system, just let me know into the comment section. I'll give you a syntax how to install that. Okay, sklearn dot model selection import train test split. This is done. Now I'm going to do this split on my data, train test split, and inside this I would be using balanced feature and balanced target. These are the two data sets I'm going to use inside this. Now here I need to specify the test size, means the two let's say if I have 100 record, out of that what proportion I want to use in training the model and what proportion I want to keep for testing the model. So usually what I'll do is I'll do the split of 80-20, means 80% I'll keep for training and 20% I'll keep for testing the data, right? So test size I just need to provide, which I'm going to say 0.20, which means 20%. And then there is one more parameter which we need to specify, which is random state. Okay, so for random state you can just give any value. Usually as conventional as convention people use 42, so I'm also going to keep it 42. Now this is done. Over here what we need to do is we need to say xtrain. So this will split the data in 4 parts. Why? Because this balanced features, the input data will also be splitted in 2 parts, and this one will also be in split it in 2 parts. So that's why we will get 4 data sets. So 2 set I'm going to create for input and 2 set for the target. Okay, not for output but for the target variable. So xtrain is my input, means set of features for the training, which will have 80% of the data. xtest is again a set of features which would have just 20% of data. Then I'm going to say ytrain and ytest. So after doing this, my data set is created for training and test. Let's just see the shape of my data, xtrain dot shape, and over here these many records we got. And ytrain, for ytrain how many records that we have? Same. xtest, you see 9,000 records we have, which is pretty well. And then ytest, how many records? We have again same number of records. So that is pretty cool. We are done. Next thing is we need to build the model. So I'm going to start with logistic regression, which is the very basic one. So from sklearn dot linear model import logistic regression. Okay, now over here I need to create an instance. I'm going to say locket logistic regression. That is what I'm giving a name. If you want, you can give any different name. So this instance is created. Now in this it takes couple of parameters. It has parameters also inside it. If you want, you can try them, or maybe sometime later we will try to check them out. Now all right, so for now I'm just going to keep it simple. Okay, now this is instance is created. Now the time comes when we need to train our model, right? So for that what I would do is there is the function which is called locket.fit, and inside this we need to supply the training data. So here this xtrain, this is my training data, this is my features on which I want model to train itself. Means I want the model to understand all these features and try to relate that with the outcome which we have stored in ytrain, right? So once this is done, all right, our model training is done. This is done. After this what we can do is we can do the prediction. So locket dot prediction, and inside that, or maybe we can just try to find the score directly, score, and xtrain, on xtrain directly I'm going to check the score. Oops, xtrain on ytrain, sorry, ytrain, what is the score? So it is giving me the score of 78%, right? That is the score it is giving us, which is not very good, to be honest. But yeah, this is what it is. And now we can also try to find the prediction. Okay, we can also try to do the prediction. uh, so let's just try the prediction also, right? Now let me say logit dot prediction. So for prediction, we need to give that data to the model which it has not seen previously, and that is available in XTest, for which we want it to do the prediction. Okay, and here I'm going to say log it prediction. This is what I have. This is done. Now after whatever prediction that I have got, this is what the prediction it has given, right? But we would not understand. So let us try to check the accuracy of this and the score of this, right? What is the accuracy and all those things. So for that there is another module which is called from sklearn dot metrics import classification report. So I'm not going to look into the confusion matrix. I'll directly print the classification report, because that by default gives us the confusion matrix also. Okay, now over here I'm going to print the classification report, and inside that we need to provide, this was the prediction made on XTest data, but what was the actual target, actual decision for this set of data. So you remember, for this set of data the actual target is this one, actual response was this one. So what if you look at this, so it says y true and y pred. So y true is y test and y pred is the prediction which we have just created. So let's just supply it over here. First of all we need to provide y test, and let's just see the score. Now to make it look good, I will do this print. Okay, approximately everything is 78%, right? So pretty much in this sync, F1 score is pretty 78% accuracy is 78%. I'm just cautious that the model is not overfitted. Okay, so that is also something which we need to consider while building the model. Okay, so now this is done. Now there is one more thing which we can do. Logit dot coef. So you see the coef. Now this is the coefficient for each of the feature, right? And using this we can also decide the importance of the feature, importance of the features. Okay, so let me try to put it let me try to put it on the features whatever we have available in our this data set, balanced features, which is for which is this also, or maybe you can say this one. Okay, so I'll just try to put it in form of a data frame, and let's try to see how it looks. Okay, so I'm going to create a data frame called features importance using logit, and over here I'm going to say pt.data frame, and inside this I would say create a dictionary, and here I'm going to say features, and for this what I have is this data frame balanced features dot columns. This will come over here, and then for coefficient I have this value, or let me say logit importance. I'm going to say it logit importance, and this is what I'm going to supply right over here. Okay, now let me just see how does it looks like. Oops, this is giving me the error. Pre-column arrays must be each be one dimensional. Okay, so this seems to be two dimensional. What I will do is I will try to pick the 0th one. If I'm picking, all right, so now let me just see, this seems to be more than one dimension. Okay, so now this is how we need to pick it from here. Let me take it and put right over here. Now we got this, you see, and over here what I'll do is I'll say sort values. Oh god, this autocomplete takes quite long amount of time, isn't it? Sort values, and by this feature importance, I should have to say importance imp, let's just say imp. Okay, that is fine, that should be more than enough. Okay, and now over here I would say ascending, god, ascending equals to false. Here we go. Right now what you see is anything around 0 may not add much value into it. So now you look into this. This rent is the categorical one, which we had just done 0 and 1. So that's something which we can ignore. This is also we can ignore. These all are the columns which we can ignore. Okay. No, not to ignore. This is actually important. This is approximately something something of importance. What can be ignored is this may be ignored. Person employment length, person age is something which we, this is something you see it is not adding much value. Credit history length, you see it is just 0.018. This is something which is not adding much value, so we can think of dropping this feature, but for now I'm not dropping anything. So what I wanted you to understand is, see, this is how you can you can check out the importance of the feature, and basis on that you can do the selection. So this is very very important. Loan percent income, which is nothing but debt income ratio, and the let's say top 5 we can pick out of it, right? So 1 2 3 4 5, this set of columns could be very very important. This, and then these are also something which are very crucial. Okay, these are something which we can consider in our model, but for now though I'm not going to drop any of the model, and I'm going to keep all of them. Okay, next we will again see, we will try to do this thing on other model, and then we will see. So logistic regression is done. Logistic regression is done, and its prediction is stored over here. Right now let me just try to train another model from sklearn dot ensemble. We have random forest, import random forest classifier. So this is what I'm going to try over here. Now let me try to have a checkpoint over here. Random forest, I'm going to say it random forest. This is done, and again over here what I'll do is I'll take this random forest classifier, and I would create an instance random forest. Done. Inside this we can put number of estimators, means number of trees, also how many trees that you want to train. By default it has 100. I'm going to go ahead on the same, but we can of course change the number of trees. Okay, now rf dot fit, and inside this again I'm going to supply x train dot comma y train, and let's see what happens. Okay, this model fitting is done. Once this is done, then we will perform the prediction again, all those three things which we had done previously. See, it is taking time because 100 trees we had considered. If you want, you can choose less number of trees. And what you should importantly notice is, here is the one place where we did the classification, and we are using the same classification in all of the models. So you see it is taking slightly more time because it has number of trees which it has is huge, and it has to train each of the tree. So if you are someone who do not understand what exactly happens in the random forest, do let me know. I'll create a separate video on that. Okay, now this is done, and I'm going to find the score, and inside this x train y train, and let's see what score that we are going to get. Ooh, it is 100%, man. It is saying all the predictions are 100% correct. Oh God. Okay, what I'll do is over here, this logistic regression prediction, logit prediction, I have already stored. At the end, I will be creating a data frame in which I would have all the predictions available. Okay. Now this is this says 100% correct. Now next one is I'm going to do the prediction. Rf dot predict, and inside that I'm going to put X test, of course, and let's just say prediction Rf prediction 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 PREDIC, spelling was incorrect, prediction, and this is done. Let's just see what we get. Okay, here also the prediction is done and it says the accuracy is 100%. Now let's just try to print the classification report. And inside that I'm going to put Y test and then RF prediction. Again I need to do the print. All right, so on training data it showed us the score as 100%. On test data it is coming to 93%, sorry 94%. The accuracy is coming to 94%, you see, and F1 score is 93% for this class, minority class, right? For minority class the F1 score is 93% and majority class it is 94%, so it is pretty much in balance, right? Accuracy is also 94%, so it looks pretty much balanced. Now over here also you have feature importance. Here also we will try to get the feature importance. So now I think you have understood, and now the next thing which we are going to do is we are going to find the feature importance. Rf dot feature importance, let's say feature importance. Here is what we got. Okay, all right, this seems to be one dimensional or two dimensional. It is one dimensional. Okay, this is just one dimensional. Now I'm going to create another data frame for this one. This was for logistic regression. Next one I'm going to create for this one, random forest. Now if you're getting confused why over here I took 0 and into this I'm not taking that, the answer is here it is one dimensional only, into that over there it was two dimensional, that's why I had to pick one. Okay, and here I'm going to say RF random forest importance, and let's just see how does this looks like. Here also I need to say RF. Thankfully I just noticed it, otherwise. Okay, we got this also. Now I'm going to say sort values, and inside this by RF importance ascending equals to false. It takes a lot of time to autocomplete. Okay, this looks pretty well. So these are something which are of less importance, but remember these are the features which we had which were previously as categorical columns, but later on we made that as a feature, part of the categorical column, right? So these are looking to be of less importance. What is more important is loan interest rate, which is absolutely 20. I think if you put it in terms of percentage it is 20%, right? And then loan percent income is 19%. So this is how it is looking, you see, these are pretty good estimators. These all seem to be pretty good estimated. This is also, so it is close to 1, but these are too far from being 1, right? So I think in our input we can consider not to include this. Okay, what we will do is after training all of the models we will combine all the features and we will see how each of them has performed, and then accordingly we will try to come up with a better set of the features, and then try to do the train test split, and then further try to train our model once again. Okay, now this is also done. Next thing is I would also try to train one XGBoost model. Okay, now let's just make it XGBoost model. This is also done. Now again over here what we need to do is we need to do the import again from XGBoost. Let me see, XGBoost import xg xg classifier, XGB classifier. We need to import this one, XGB classifier. Okay, now for that, again I would require to create an instance, XGB classifier, XGB model. I'm going to say it XGB model equals to XGB classifier, XGB classifier. What is the difference? Okay, XGBR classifier and this is XGB classifier. Now into this we need to put the X and Y, but in little bit different format, I think. Here there is one thing which we need to consider, and that is there is one method which says exact, and that's what we require over here. Tree method, I'm trying to find, there is one parameter which is called tree method. Here you see tree method we have. So this is something which we need to specify over here. Tree method, tree equals to exact. Let's see if it gives any error. So seems to be correct, but somehow it had a struggle to do the completion. Okay, now after that this instance is created. Now the time comes when we need to train this. So I'm going to say xgb.fit, and inside this we need to supply the features again. So they here when we are supplying, one thing you should note is here x value you can supply as it is, so which is nothing but x train. And over here y value, when we are supplying the y value, what we need to do is we need to say y train dot values dot ravel. That's what, right? Now it will do its training on the train data, and then we will try to find the score of it again. Ooh, now you see over here it is providing you all the details. Base score is 50%, booster GB tree, gradient boosting tree has been used over here. Learning rate is 30%, maximum bin is this much. It is providing you all the parameters. So it has also used 100 trees. If you want, you can increase or decrease this number of trees. Minimum child weight was 1, maximum leaves were 0, and maximum depth was 6. So if you want to understand any of the parameter out of it, do let me know. I will try to create a separate video again for that also. Now the time comes when we should check the score of this score, and into this we are again going to put these values. 96%, score is 96%, you see. Now I'm going to make the prediction over here. So XGB model dot predict, and inside this what we need to put is x test, and let me store this inside this prediction equals to this, and let me just try to print it. Okay, we got this one also. Now the time comes when we need to check the accuracy score on this. This is the data which model had not seen, and this is what we are going to check for the accuracy score. Again, I will print the classification report, and inside that I'm going to put XGB prediction. But before that, I need to use the truth values. Okay, and let me just print it. All right, so this is pretty close. On the training data it was giving us 96, and on the test data it is giving us 95. right? 95. So this looks pretty well, right? Because if you remember, for this model, um, this random forest, on the training data we were getting 100% on, and on test data it was reduced to 94%. So my suggestion is, I mean, if you ask my thought, then my thought will be this is better than XGBoost is better than random forest, because on both of the model it is approximately performing the same sort of similar sort of it is giving similar sort of accuracy. Okay, now usually any difference below 10% is considerable, so from that perspective this also looks okay, because here on training data it was giving 100% and on testing data it is giving us 94%, so this is also pretty well. But over here this looks very very close, right? Because for training data also it was 96% and for here it is 95%, so this looks very close. Now again the time comes when we should separate the feature importance out of it. So I'm going to say xgb model dot feature importance. Okay, and let's just see, this is also one dimension, so now I'm going to put it in a data frame. Okay, now to put that in the data frame, again I'm going to say xgb importance. Okay, what was the previously how we had created the data frame? Feature importance RF. So let me keep the naming convention same so that it does not create any confusion. XGP. Okay, and over here I will say pd dot data frame. Inside this, let me copy paste all of them from here directly so that it will save time also and we will be able to quickly do it. Everything is done. Let's just copy paste this part over here, this many part. That's it. This is done, and over here let's just close this curly bracket and let's just print. Oops. This is also closed, and let's just print the head. Very well. I'm going to say sort values and sort values by equals to, oops, not RF importance, rather it should be XGB importance. XGB importance. Okay, otherwise the data will be confusing. Okay, and here I'm going to say ascending. Oh god, why did I hit tab? False. Let's see. Okay, this looks pretty much in sync with our random forest, right? Now, so here we got this data also. Next one, what I'm going to do is I'm going to concatenate the feature importance which we have received from all of the three models. Now over here, feature importance data frame pd dot concat and inside this I'm going to put all of the features. Let's just try to put all of the features. Where is that RF random forest importance feature? I'm going to let's just start putting it one by one, otherwise it will be a mess created. Here this one, comma, RF feature importance RF, and then feature importance log it. So all the three are done, and here I'm going to say access equals to 1, and over here let's see how it looks like. Oh, we got, the only challenge is feature we are getting again and again in all of the data frame. We can for now let's be with that, and then later on we will see what to do with I mean how to manage that. Okay, now what is it that we got to see over here? Person age, logistic regression is telling you that it is approximately 0.06. This is also RF model is also saying 0.06, and this is, so these all seem to be in pretty much sync to drop the person age. Person age is something which we can exclude. All right, next comes person income. Here RF model is saying it is more important, and XGB model is saying it is less important. Okay, and logistic regression is also saying it is approximately less important, right? So we can think of dropping this as well. Person employment length, person employment length is something, it is saying 0.04, 0.07, 0.04. XGB model and logistic seems to be quite in sync, isn't it? So now this is also something which it suggests can be dropped, because two models are showing it less important. This one 0.69, and here it says 0.08, 0.008. So again, these two models are not recommending this particular feature, loan amount, but I think we should keep it, because this is a critical thing, how much of the amount is needed, right? And I can't say that it is less. XGB model is saying it is absolutely, not much important. It is 0.008. It is not much important from the XGB model perspective. Loan interest rate, loan interest rate, RF model suggests it is very important, and then logistic regression is also, it is suggesting it is very important. Logistic, I mean, interest rate is something which should be important, which should be considered as an important feature. All right, from XGB perspective, which one is the most important? Loan percent income. Loan percent income is important for all of the features, from all of the models perspective, right? So you see, that's why it says debt to income ratio is very important, right? Debt to income ratio, in fact it is, because that gives very good insight. Then over here, this is the one, and then the next one is this one, own, whether the flat is own or not, that has also played a critical role from the XGB model perspective. So it says 0.17 and 0.02, and here it says -2. So that means from logistic regression perspective also it is very important. All right, so this is how you can find the importance of the feature. What I will try is, I'll try to train another model after, in the next one. Let's catch up and try to pick some more important features out of it, and try to retrain our models using those features, and then let's see how the accuracy or anything else is improvised, or how it goes. Okay.